Let's look at this function. F of x is x squared plus x minus 2 divided by x minus 2 when x is not equal to 1 and it's equal to a. We don't know what a is, but we're going to figure that out soon, when x is equal to 1. So the question says, which value do we assign to a so that the function f of x is continuous at x equals 1? So in order for the function to be continuous at x equals 1, by definition of continuity at a point, f of 1 has to exist. So f of 1 equals a according to this definition. Limit of the function f of x as x approaches 1 has to be defined. And finally, the value of the function at 1, which means f of 1, must equal the limit of the function as x approaches 1. So if these two are equal, then the function is continuous at x equals 1. So f of 1 is equal to a, and we need to make sure that is equal to the limit of f of x as x approaches 1. So what is the limit of the function as x approaches 1? So let's see how the function is defined as x approaches 1. So when x is equal to 1, the function is a, but when x is close to 1, either from the left or from the right, we have x squared plus x minus 2 over x minus 1. That's exactly how the function is defined as x approaches 1 from either direction. So a is equal to, now when we try to find the limit as x approaches 1, we first try substitution. If you look in this corner here, when we substitute x equals 1 in the numerator, we get 1 squared plus 1 minus 2 equals 0, which is a 0 in the numerator. When we plug in x equals 1 in the denominator, we get 0 in the denominator. So it's a 0 over 0. So for a rational function, when you get a 0 over 0, we know there's a common factor that's in the numerator and the denominator that's causing the 0. So when we factor the numerator, we get x minus 1 times x plus 2 divided by x minus 1. So let's write this down. Limit as x approaches 1, x minus 1 times x plus 2 divided by x minus 1. So remember that x is approaching 1 but not equal to 1. So x gets closer and closer to 1 from the left and from the right. So since x minus 1 is not equal to 0 and x is approaching 1, we are allowed to cancel the factor x minus 1 in the numerator and the denominator. So a is equal to, now we find the limit as x approaches 1 of x plus 2. So a is equal to, now we find the limit by substitution. So when we substitute x equals 1, we get 1 plus 2, which is equal to 3. So if we replace a by 3, then we have f of 1 equals 3, limit of f of x as x approaches 1 equals 3, and f of 1 is equal to f of x as x approaches 1. Both are equal to 3, and therefore the function is continuous at x equals 1.